Good morning.
Hi, hi, Michael. How are you?
Doing very well. How about yourself?
Very well, very well.
Excellent.
So
So
you're back
it,
home, back the nice environment.
yeah. I think this is going to work out a lot better for streaming. I mean, I built this rig specifically for streaming, and so yeah, trying to do that off the laptop, not very effective.
Because if you look at YouTube, you missed half of the screen and half of the sound.
Hmm. Yeah, so that's over two.
But before I forget,
Mm-hmm.
next week I'm away Monday and Tuesday, so I will not be able to attend. I have to follow some training, which is nothing IT related.
Mm-hmm.
But I cannot move it in these 2 days, and otherwise I have to wait another 2 or 3 years. So
Oh yeah, yeah.
I had no choice. So next week I will not be there, but the week after I will be back.
Okay, that sounds good.
Michael,
Mm-hmm.
I looked for a nice program to show you something because working together on a drawing has always been difficult.
Yeah.
Because I wanted to go one step back because with correspondence and Janaga JS and Janaga.net, I'm losing myself in the code and I'm
Mm.
losing the overview. So I made a little drawing. Um, I'm gonna invite you for that. So I have a link here, which I will post to, where can I send it to you? How can I?
Yeah, you could either put it in
Yeah,
the general or
I will just send you a direct message.
okay.
Okay, it's a link from Excalibur,
Yes.
which is a program that allows us to share the drawing. And it's actually nice because it works very well just with the mouse and the keyboard,
Mm-hmm.
and it's open source.
Okay. Yeah, it looks like that's worth a shot.
And it's perhaps best that you stream the screen then,
Yeah, so I've
because
got it going on to YouTube right now. Um, so yeah, so you can go ahead and use the screen from your side, and then I can share it out to YouTube, and everybody can see it.
yeah, yeah. Because right now I just see the video, but you the screen that you send to YouTube is the
Yeah, so
is the drawing.
yes, I've got the drawing
Okay,
going to YouTube.
okay,
Yep.
okay. And it's all right. Now we can both adapt the drawing if we want.
Yeah.
Um, I don't know anymore what is working already, what is not working, and is it working the way I think?
Hmm.
Yeah, because I'm confusing everything. Um, and okay, I with the whole link world inside. I'm even wondering where are the expressions trees in this thing. So we have two clients. There is the Janaga GS client, and there is a Janaga.net client. I've only drawn the Janaga.net client, and there is the Janaga JS server. Yeah,
Let's see. So do you have? Um, yeah, I'm not seeing anything on the screen except for a small green arrow. Oh, there it is. Okay, I was just on the wrong place. There it is. Got
yeah.
it.
Actually, if you press Shift one, then you will zoom to the whole drawing.
Okay, perfect.
Okay. And I see where your pointer is, and you see where my pointer is. Yeah.
Yes.
So here we have the Janaga client,
Mm-hmm.
the JS client. This is the Janaga.net client. And here we have the Janaga JS server.
Yes.
So in the server, am I correct? We already have a PostgreSQL database.
That is correct, yes.
Is there already a SQL server, Microsoft SQL Server database? Not yet, I think.
No, there is not.
Okay, that's why I did it dotted. But that's something you would want to have as well, if I understand well.
Yes.
And there is also a memory store or not?
No, not in the server.
Okay. And then on the .NET client, we have the memory store, which is working.
Mm-hmm.
And we have the SQLite store, where I'm doing an attempt. Now
Yes.
both just implement the iStore interface.
Mm-hmm.
All right. Is there something a similar interface on the server?
Yes. So it's the equivalent in JavaScript, but it's not called iStore. I forget what the name of it, but it's something very similar to that. It might actually just be store. I think I was taking the convention that I just didn't put an I in front of interfaces in JavaScript.
Or interface. And let that put in black. So that's good. Then in the Janaga.net client, j.fact is working. Yeah, dus if you call j.fact, it will just serialize the facts and put them in the store.
Yes.
Correct. And then we have three other comments: a simple match, a watch, and a subscribe.
Yes. So yeah, in Janaga.net. Okay. Actually, so it might be better to put query at that top level where match is. Yeah, JDAP-match is a mechanism for you. Well, actually, yeah, JDAP-match is only a mechanism in Janaga.js to build specification functions. Yeah.
Even the names I don't remember.
Yeah. Yes, and so in Janaga.net, JDAP subscribe is not yet implemented.
Okay, so this one we will dot.
Mm-hmm.
So a j.query will just send the specification to, I call it the query executor, which is actually inside the iStore. It should be inside iStore, I think.
Yes. Yeah. There's. Is
that the query all method?
Yeah, that's the query all method. There's some work that goes into preparing it for query all to turn that expression tree into a pipeline, and that work is done outside of the store because it's the same for every store. But yeah, I don't know if that's the detail that you're going for at this level.
But he's turning it into a pipeline, but not in a pipeline. There is no inversion of that pipeline in case of the query, I suppose.
Yeah. Yeah. So what I would say is the pipeline is it's a compiled specification. So the act of compiling that specification from an expression tree and inverting that specification, inverting that pipeline to create other pipelines, that's all done outside of the iStore. Okay, but yeah, I'm locking onto the fact now. You've got query executor and pipeline inverter as outside of the iStore. So yep, that is correct.
Okay.
Yeah. So it might be better to say, rather than query executor there, you've got the pipeline creator or the pipeline compiler. Something like that. Yeah, and then so by the time the iStore gets it, it's already a pipeline. And so the act of executing the pipeline is something that the iStore does. It really converts the pipeline into SQL, in the case of SQLite, and then tells the database to execute it, or in the case of memory store, just executes it directly against the memory.
Okay. So perhaps we should add one here, which we call pipeline to SQL.
Mm-hmm.
It's not right because for the memory store, pipeline to store. Would that be?
Yeah, if you want to just use the name query all,
and that goes.
if it query all is the method that
Yep.
gets invoked in. So whether it's memory store and it actually executes
Yep.
the query, or SQLite and it converts it to SQL, that's happening in query all.
I think that's a good idea. So we can just put this one here. Yeah, I will do the layout later on. So these two, these two are in fact the translation, which is part of the store. It's the method. Okay. But so if we do a j.query, we just give it a specification. It sends that to the pipeline compiler. It goes to query all, and it sends one-time result back in blue.
Yes.
If we do a j.watch, it will send. Yeah, it will go first to the compiler, I assume.
Yes, it will.
So we should have a compiler in between here.
Mm-hmm.
I will make it nice afterwards. Actually, yeah, it will retrieve the results, send them back, and subsequently invert the query. And for all incoming facts in the database, whether they come in from the server or from new facts, it will send them back to the watch.
Yes. So it might be important at this in this diagram to point out that it's not the store that's detecting the new facts and sending them back. It's the Janaga runtime instance. So it's sort of a facade that knows, hey, here's a store, here are all my subscriptions, here are all the incoming facts. So something comes in from the user or from a notification, and then it goes through this process. It gets put into the store, and then it also takes a look at all of its j.watch observers, and then says, okay, yeah, you need to know about this one, so I'll send it to you. So yeah, the store is not really the driver in that interaction.
Yeah, so I should have another layer in between here.
Yes.
Is that correct?
Yeah, I would say, I would say it's really a layer that's around the store, the pipeline compiler, and the pipeline inverter. Those are all components that are working within that. Thinking about the word orchestrator right now. I don't know that I like that word. That's not one that I use in the code, but that thing that that knows how all these things work together.
I'm gonna mess up the picture. Oh, why is it doing that? Never mind. I'm just gonna wait. Let's put it in this color, and I will adapt it afterwards. That's gonna be better. Just so actually, I need. All this. Yeah, that's what needs to be inside. And I call that the Janaga orchestrator.
Yeah, for now, let's use that that term. I think there is a better term for it. The store keeps falling further and further down the page. Oh wait, no, there it goes. That was weird. All right.
Shift 1 and you have everything. Well, perhaps I should put that one a little bit closer. Like that.
Let me see if I can find.
The store should it.
Yeah, in the.
Should the store be in?
I think that everything should be inside of that that thing. In Janaka.net, I'm calling it Fact Manager.
Okay. Yeah.
That's a decent name.
The Fact Manager, and the Fact Manager is calling the store, so the store is not. No, the store is injected in the Fact Manager. If I.
Yes, that is correct.
So what do we do? Do we put it like that, or am I just gonna?
I think so. That seems to make sense to me. The Fact Manager is the it's the one class that knows how everything else works together. So it brings in the store and the compiler.
I store inside the Fact Manager or outside the Fact Manager?
I think inside. Depends on the rules of the graphic language that you're going for. But yeah, inside makes sense.
All right. Then subscribe. Subscribe will get a specification. That specification will be sent directly to the server. Or probably through the Fact Manager.
That will also go through the Fact Manager, but you are correct that it doesn't go through all of those other components. It does set up a subscription.
A direct route.
Yeah. So there's something in memory that knows that you're subscribed, and it's pinging the server. So right now through polling, but in the future that'll be through push notifications. But it's still there's still memory in the client, and that memory is managed by the Fact Manager to know what it's subscribed to.
The Fact Manager will remember the specification it's subscribed to. Why to be able to unsubscribe?
Yes, and also to be able to keep that subscription alive. So the server, in order for the server to be scalable, we don't want it to have any per client memory storage. So well, only enough to allow it to do push notifications. So yeah, with push notifications, you've got a socket. So there's memory even in the operating system then to manage that socket. But then now the server knows these are the pipelines that client is looking for, and so it computes the inverse, and it whenever it sees something new, it sends it down the socket. So the server does have that much memory going for it, but the server can be rebooted at any time, and then it'll lose that memory. It's the client's responsibility to keep that communication alive. So if it stops, it has to say, "Oh, wait, no, I'm still here."
Because these notifications, it will just be an HTTP request with a very long timeout?
Yeah, about 10 years ago, that would be how I would do it. These days, we've got WebSockets. Actually, I'm trying to think. Server sentiments. I think server sentiments are implemented on top of WebSockets. But yeah, these days we've got a better mechanism to. In fact, just HTTP 2.0. You can open an HTTP connection and you can still get a request from the server side. Versus HTTP 1.1, it was open a connection, then all the requests come from the client, and then they're handled sequentially. So 2.0 has proper duplex. So I think that's actually what WebSockets is using these days, is just HTTP 2.0.
Because if you use Android has its own notification mechanism. iOS has its own notification mechanism, which is actually in Android very tightly integrated with battery saving.
Yeah, that is a good point. So yeah, you're right. On native platforms, we'll want to use that strategy as opposed to the HTTP 2.0 strategy. Yeah.
Yeah. So actually, either we do it native, either we do it HTTP 2.0.
Yeah.
Everything that is just .NET. And in Xamarin, do you have access to that native push notification?
Yes, you do.
Okay.
Yeah, I think they have a nice abstraction around it. But even if they don't, you can always write native code in Xamarin and then create your own abstractions. So that's pretty much what Xamarin is an abstraction building tool, and then they just happen to have some really nice abstractions that they built in the box.
But so this is not yet implemented.
Correct.
Yeah, how can we'll put that in another color. Green. Notifications, not at all for the moment. Not at all in the server notifications?
Right, yeah. In fact, that's the reason that currently Janaga.js is using polling, is that the server doesn't know anything about notifications, and so polling looks just like a user that's hitting F5. So the server responds in the same way.
The client is every X seconds is gonna check, and that's what it's using for subscribe then.
Yes.
Okay. So with subscribe, it goes to the pipeline inverter, and it's the pipeline inverter with the comms effect in from somewhere else that sends it back. Is it the notification itself, is it going to contain the data? Or is it just a message, time to poll now?
It will probably be closer to the latter. Certainly for native, it'll be just notification time to poll now. In the case of HTTP 2.0, it could contain the full message body, but yeah, there's even then having it just be a triggered poll is yeah, it simplifies a lot of things.
Okay. And here, that query executor, that should be changed in pipeline compiler. Actually, if we poll for facts, is it here that we send that special syntax over that we discussed about 2 or 3 weeks ago? With
Yes.
successor dot.
Yes.
So that's a specification. That's a specification, and that goes. So that doesn't go straight to the store. That goes to the pipeline compiler then.
Yeah, that syntax is actually a pipeline, so it's already been compiled. It's just been serialized. So it's really, you just deserialize that pipeline, and then you can start using it. So
you have to convert it to SQL there.
Yeah, the conversion to SQL is happening inside of the store. So the Postgres store is doing that SQL conversion. Yeah, so it's just that the pipeline itself is a collection of objects that are all in related to one another. They're in collections. Yeah, they're in memory, and so it's just the serialization of that pipeline. Yeah, it's just like JSON as a string versus a JSON object. You know, that kind of a distinction. So yeah, I would say that the pipeline deserializer that happens there is probably not an architecturally significant component. I mean, it's just something that converts text into objects.
Okay.
So yes, I think the way that you've got it drawn there is accurate, because it's just taking that pipeline and it's sending that to the store, and the Postgres store is converting that pipeline into SQL, executing it, and giving you back the results.
Yeah. But so we don't actually need a pipeline compiler in the server.
Yes. I would say, yeah, for the only time that you do is if you've got actual client level code running on the server. So that's not an unusual thing to do. That you've got a client-side component and it's client-side code and server-side code.
We have a visitor.
Yes, indeed. That's... How do you do?
Hey.
Hi. I like the initials. That's
I finished the book last week, Art of Architecture, and I liked it very much. I was curious to see what this was about. Maybe have a few ideas of possible implementations.
Yeah, absolutely. But yeah, so as you know now from reading the book, it's really for 3 different audiences. Right at the beginning, we're talking to like the decision makers, the people who are building teams, deciding whether they're going to be using this tool set or that tool set, these patterns, those patterns. And then you get into the people who are building the applications, and that's the meat of the book. But then there at the end, we're talking about building tools, building implementations on top of SQL, on top of networking, building query inverters, all that stuff. And so Jan and I are working on an open source project called Janaga. So I've got the JavaScript version of that. It's been out there for a few years now, and we're working now on the .NET version of that library, and that is an immutable runtime. So yeah, this is all about building those tools and also building applications on top of those tools.
Cool. Do you plan to open source also the .NET implementation?
Yes, absolutely. So yeah, Janaga.net is currently up at GitHub. So it's still in sort of a nascent state, but there's some really cool things that are happening in there. So yeah, in github.com/Janaga, you'll find the projects that we're working on.
Nice. I was also curious about the inverters.
Mm-hmm.
I think it was the first time I was exposed to them, so it was a little bit difficult to follow through them. But I had the idea that is more of a general concept that doesn't only apply to immutable architectures. So it might even be if someone is building a cache on a regular application, so non-immutable, and you wanna use a similar logic, will that also work?
So the ideas that are there, they really do kind of depend upon the immutability aspect of the architecture. So yeah, it's so kind of like if you think about object-oriented programming versus functional programming. One of the things that people will often talk about when they say, "Hey, functional programming is easier to reason about." One of the reasons that they say that is that in functional programming you tend to favor immutable data structures that don't have side effects. So you've got pure functions, and you don't call a function and then something happens, but then you return something else. And so having that pure function concept and those immutable data structures makes it a lot easier for you to see what depends upon what. And so that's what they're talking about by reason about, is that you're looking at the structure of code, and you're seeing that here I call a function, I've got variables A, B, and C in scope, and I call a function, I pass in B and C. Oh, I can reason that function does not depend upon A. That I could, if I'm computing A somewhere else, I can move that function before or after and not change the behavior of the system. So that's the kind of reasoning that we're talking about. And so the idea of a query inverter is that you want to be able to tell when something has affected what the user is seeing, has affected the behavior of the system in some way. And it's a lot easier to reason about that, to see when something has affected behavior if you eliminate side effects. So if you've got pure functions. So this is just taking that now to the architectural level, that when I run a query against some data and I get some results, I want to know when I've learned something new that would impact those results. And that's really all that a query inverter is trying to solve for you. If you were to try to do that in SQL, since SQL is designed to work against a database that you can update rows in that database, it's a lot more difficult to reason through what updates and what deletes and what inserts would change the results of that SQL statement. But if you eliminate updates and deletes and you only have the inserts, then it becomes easier to reason about. It actually turns into something now that a machine could do. You could now turn the crank and figure out, these are all the things that could happen that would affect my results. And that list of all the things that could happen, those are the inverses. So yeah, query inverses do depend to some degree on the fact that we're doing an immutable architecture.
It makes sense. I was opening the Janaga.net repo that you mentioned,
Hmm.
and I have a question. I mean, I come from a .NET background. Why are you using .NET Framework?
Yeah, that one is using .NET .NET 5. Yeah, so we started to take that on.
Because okay, cool. I thought I saw some .NET Framework reference, but it might be.
No, it was still on standard 2.1, I think, Michael.
Yes, yeah.
And
Yeah.
testing framework was on Core 5 now, or .NET 5.
Oh, yeah, that makes sense. I might actually be interested in helping out on the .NET because I recently moved to a Java project that I'm missing. Writing some .NET code, and this is something that I find quite interesting actually.
Hmm. Awesome. Yeah, so you'll see right now, Janaga.net doesn't even have a README. It's not yet welcoming to like a new developer. Hey, this is how you get it up and running. But yeah, that's yeah. If you want to just kind of clone that, take a look around. Maybe we can then organize some time to for me to kind of step through what's going on there. In fact, yeah, the three of us, I think that would make sense because Jan is going through that source code as well to write one of the first implementations of the query engine, the data store built on SQLite.
Cool. And usually you meet once a week to discuss roadmap for project or general immutable topics. How do you
Yeah,
do it?
this meeting is originally intended for general immutable topics. So we started this as a book club and actually went through the book chapter by chapter once a week, and then started transitioning it into the tool building and the application building. And so yeah, this is still here for people who are who are like yourself, just finished reading the book, or other people who just learned about the book and maybe are starting to read it. And then we're also using this time to get into the source code and work on the project. So yeah, if it turns out that we've got a lot of folks who want to come and talk about the book, then it might make sense to have a separate meeting that's more specifically about the open source tools. But so far, the demand hasn't required that we split those things up.
Cool.
Be nice if the demand did increase like that.
Nice.
But yeah, in fact, what Jan was going through here is precisely the structure of the applications. So let me go ahead and share that stream so that you can follow along live as well. So yeah, we've got the Janaga.js client, and that is a project that I think I started that back in it might have been about 7 years ago now that I started the project, but yeah, it's really kind of been reached the level where you could use it in a production system probably about 3 years ago. I think is when I put that line. And so it's got two components. It's got the client component, which supports primarily React, but that's your JavaScript client. And then you've got your Janaga.js server, which runs in Node. And those two things talk to each other in order to store data on the server and generate an API kind of on the fly, so you don't have to create an HTTP API for your client. you run your queries on the client, and they're served from the client store, but then they're also refreshed from the server. And it's also got collaboration built in, so you can subscribe to things that other people are doing. And so if they're connected to the same server, then you get notifications about those changes as well. So the plan here is that the Janaga.js client should be able to interact with the same server. And so that's why we've got both Janaga.js and Janaga.net talking to the Janaga.js server. Yeah, so Jan, you were talking about the pipeline inverter, and would there ever be a pipeline compiler on the server side? So yeah, if there are business logic components that you want to run on the server, rather than running those in the client, then that business logic would be calling j.query, j.watch within the server, and that's where it would use the pipeline compiler. So
yeah, but that would probably be a different application, a client application which runs on the server.
Yeah, that would probably be the best way to do it, although I must admit that's not the way that I have been doing it. So I have been creating a node application that then brings in Janaga, the server components, as an npm package, and then both exposes the endpoint for polling notifications, for saving all the that Janaga generic endpoint, and application specific endpoints. And it's also been the backend that serves up the HTML, JavaScript, and CSS. So yeah, I've been putting everything into one process. But yeah, you're right. It makes sense to split that up and have different processes, and that is actually getting closer to that decision substrate idea, where what you've got written here is just the distributor portion that's living out on the substrate, and then yeah, you would have a different client that's either using Janaga.js or Janaga.net, but is serving up web pages or APIs or whatever.
So do you agree if I just delete the pipeline compiler here on the server?
Yeah, I think that makes sense given the scope of this diagram.
And then here the passing of the specification coming from the subscribe comment. That's also that same pipeline syntax, I assume.
That is correct. Yes.
Okay, so let's add that here as well. Pipeline syntax. Like that. Like. Okay. But for the moment, the inverter is not yet implemented.
The inverter is implemented there. Yes.
Okay, so we don't use the polling anymore for the subscribe.
Right. So yeah, the subscribe endpoint is not implemented on the server yet. So yeah, the reason that I say the inverter is implemented is that it's the same inverter as in Janaga.js client. But yeah, given what the server currently does, I think you're right. There is no mechanism by which the server would use the inverter currently.
So actually, this line does not exist yet.
Right. Yeah. That's the part that doesn't exist yet.
All right, and the notifications here also don't exist yet. That was the. So okay. Let's see. Then, because then we get back to security.
Mm-hmm.
So in the beginning, every client got all the facts that were available on the server.
Mm-hmm.
But then it was the purpose to implement authorization rules so that on the client we only have part of the facts, the facts that are important for that client.
Yeah, there are two parts of that. The authorization rules are only allowing the client to create facts that the user of that client should be able to create. What you're describing here are the distribution rules, and that is constraining what facts we send back to the client based on who's using it. And those take on different shapes. And in fact, the one that's implemented right now is the authorization rule, but not the distribution rule.
Okay, because these distribution rules, that's gonna be a layer sitting here,
Mm-hmm.
which has specifications, which will automatically be part of the pipeline then.
Yeah. So yeah, the pipeline. Yeah. Yeah, I think that's accurate because a distribution rule is basically a constraint that says that if you see a pipeline that looks like this, it must have come from this kind of this user, based on the starting point. If that user, if it was a different user that gave you this pipeline, then reject it. Or if it's a completely different pipeline, reject it. So yeah, you're right. There's a tight relationship between the pipeline and the distribution rule. But the distribution rule is not contained within the pipeline because the client is the one that gave it to you, so you can't trust it. The distribution rule is configured on the server.
Yeah, the distribution rule is a pipeline itself that is sent to the server by I don't know which authority, and that will just become part of that will be merged with the pipeline that comes from the subscribe.
Yeah, and the authority is the code that's deployed. So, and so if you think about this as the way that I'm currently doing it, just all one process, and you're loading Janaga as a library into that process, then that process also gives the library the authorization rules and the distribution rules to enforce. Now, taking that out of the process and having that be a standalone distributor, that means that something else is going to have to be the authority for those authorization and distribution rules. And there are a couple of different mechanisms that we could use to do that. One is if you think about the distributor as being a Docker container, then we'll ship a base image that says, okay, this is just the raw container, but then you create your own image that says, I'm going to have a JavaScript file for authorization rules, and so it injects that into the Node application and says, okay, here are the authorization rules, and then here's another JavaScript file. Here are the distribution rules, and now it's got the server configured. But yeah, given the fact that was put into a Docker container, now it's something you can trust. It's not something that came from outside the system. So that's one mechanism that will be supported at some point. But I can imagine others as well. And this is something that seems to happen 45 minutes into every call.
Here we are back.
There you are.
Yeah. But so the distribution rules will have to be checked as well.
Right.
in this path as in this path.
Correct. Yes.
So we can just draw them like this. Do you
Yep. Yep. That makes sense.
agree? All right. And actually, the authorization rules.
Yeah. So the authorization rules. One of the reasons that we split them up into two separate sets of rules is that they're checked on a different path.
Here. It's only here.
No, it's only on the on the save path, which you don't have drawn there. But when you call j.fact, you put something into the store. You also put it onto the queue. So I should probably try my hand at this. So somewhere in here we'll have a queue, and then that will save the facts, and so that's where the authorization rules are applied. And let me. Oops, so something like that. Yeah.
Okay.
So something like that.
We could just take an arrow here.
Yeah. Yeah. Go ahead.
Goes from there all the way, so like this.
Yep.
Okay. Because the authorization rule does not prevent you from saving a fact or creating a fact locally. Yeah?
That is correct.
It only protects the server and the distribution.
Right. Right. You can't trust any code that's running in the client. So you can put authorization rules into the client, and that helps. But you can't rely upon that as a security mechanism, because somebody can work around that authorization rule on the client.
Mm-hmm. Let's see. Okay, who initiates the communication? Yeah, that with the notification we spoke about it. That polling. Do we already have that now in the .NET client or not yet?
Not yet.
Okay, so yeah,
yeah. So yeah, if you had a similar picture up in Janaga.js, then more of the lines would be filled in. Yeah.
Yeah. Here everything is implemented, but I only do it here for the moment.
Yeah.
Okay. Realization.
Question: when you polling, is it getting the latest ones since the last bookmark?
That is the intent. Yes. I would say that. I call out that's the intent because right now I've really only implemented polling just to be able to do a conference talk. So I'm showing people that hey, you've got this collaboration. Get them excited about helping out on this project. But yeah, so the current version actually just runs the query every time. It's not efficient at all. But yes, that is the intent there. That you would keep a bookmark on the client side. You would poll for only the facts that have occurred past that bookmark for that particular server, and then the polling will as we implement the push notification, whether it's native or HTTP 2.0, the push notifications will be the thing that you rely on for real-time communication, and what's currently implemented as polling will just be the part that then sets up that subscription. So that code will kind of be repurposed into just so something that periodically checks to make sure that the communication is still alive, and if not, set it back up again.
Right. And in terms of the .NET application, have you picked the technology? Because I'm thinking that by using Blazor,
Mm-hmm.
you simplify a lot the communication between server and client.
Yes, absolutely. Because Blazor already has the client server communication built in, so it already knows that if you update something within the render model, then it will push that to the client. I consider Blazor code as really using Janaga.net on the server, and then you've got your Blazor code that you ship to the client, and then it's doing the regular Blazor communication with the server-side components, and the server-side components are using Janaga.net in order to collaborate with other users in order to store your data. We're targeting a few different stacks. So Blazor is a big one, but also Xamarin. And so for Xamarin, Janaga.net would be running fully on the client, and that would be taking advantage of these mechanisms.
Right. And for the server to initiate the communication with the client, which communication protocol
Yeah.
used?
Yeah, so there, that's we're targeting HTTP 2.0. So the client will open the connection and keep it open, but then the server would be able to send an HTTP request to the client over that connection. So take advantage of HTTP 2.0 duplex.
Makes sense. Thanks.
Yep. Yeah, it used to be WebSockets, but now I think even if you use the WebSockets API, it's HTTP 2.0 duplex that it tries to use, if the server supports it. And so that will be a requirement for deploying a Janaga server.
Yeah, there is a .NET technology.
Signalr?
Can use again?
Signalr?
I was thinking of Signalr that essentially allows you to multiplex the messages being sent.
Yeah. Signalr is a wrapper on top of a few different mechanisms that you could use for that. So where I would say is that Signalr is intended for an application developer to use, and then it abstracts the details. And so it can do polling, it can do long polling, where you just you don't expect a response immediately. You expect a bit of a timeout before you get the response, and then WebSockets and server-sent events and HTTP 2.0 duplex. So all of those options, it figures out what the server supports. So now that we're starting this late in the game, we already know that HTTP 2.0 duplex is a thing, so we don't have to worry about all those other mechanisms. This is something used by Janaga.net, and Janaga.net is the API that the application developer uses. So it doesn't matter to me if the way that you access the duplex mechanism is cumbersome. Yeah, we're only writing that code once. The app developer still sees a really nice, clean interface.
Cool. Makes sense. Thanks.
Michael, I think for the drawing, are there other things that are missing here? Or that I misunderstood where?
Let's see. So I think the authorization and distribution rules was a really good addition. I think that completes the picture there. I'm not sure how this works in the drawing, but Janaga.net server is a thing that I want to happen. So as we've been working on Janakanet, the client, and actually even before that, as I was writing the book, I recognized that there were some flaws in Janaga.js. And in fact, just this weekend, while preparing for a talk this week, so yeah, by the way, I'm speaking at Codepalooza Thursday and Friday, but those times are going to be really bad for you. They'll be after midnight for you, certainly on Friday. But and it's a conference. You pay I think $100 to get a ticket to the conference, and it's virtual. But one of my good friends, Chad Green, is running it out of Louisville, and so anyway, yeah. What I'm presenting is the end-to-end state management talk, the one that you and I worked on the demo for, the shared list demo. So I'll be presenting that one again, and then also the one that I did as the keynote for the architecture and containers conference in Poland.
Okay.
So yeah, doing those two. But as I was preparing for the first one, the Janaga.js talk, I had noticed another flaw in the Janaga.js implementation. So, and this one is more of a design flaw. So it's going to be, whereas some of these, it's just, we can kind of shore things up a bit. This one, I'm really going to have to kind of think through what's the right mechanism to fix this. But at any rate, now there's this laundry list of things that are wrong with Janaga.js server, and I'm trying to figure out, does it make sense to fix them in Janaga.js server, or does it make sense to start with a brand new Janaga.net server and then backport these fixes to JS? So,
what was the problem in the server?
Yeah, the problem, this particular design flaw is that when the client renders a user interface, it creates a pipeline just for that user interface, and that pipeline could include a condition. So don't show me the things that have been deleted from this list. And so the server only sends back the things that are on the list. If the client has some other query that gets all of the items without getting the completions for those items, so it's not asking for enough information to know that they've been removed from the list, then the server will send back the response to that query, and now the client has the items that are, it basically knows all of the items through history, but only the completion, but it doesn't know about any of the completions because it never asked for them. So yeah, how that manifest was I brought up the user interface. Here are all the items that are still to be completed, and then a polling event happened in the background, and then boom, here are all the ones that were completed already, and it just didn't know about the completions. So yeah, it somehow the client needs to package up all of those pipelines and figure out that because I'm asking for this detail, I really need to also know about these tombstones, these deletions. So that I think is something that has to take place on the client side. So it might not actually be a server design flaw, but it's some kind of design flaw in that protocol, in that way that you're asking for the information. So yeah. Actually, talking through it now, it might not actually be a reason to just jump ship to the Janaga.net server.
Something to think about.
Yeah. Yes, indeed.
But so we could end up with two servers, two clients, which are completely interchangeable.
Yes, that is the ultimate goal. Is they should be completely interchangeable. So it's just your choice. Are you running a .NET shop or are you running a Node shop? And then you just pick which one fits best into your architecture. And honestly, if you're running a Docker shop, then it shouldn't matter. It's just a black box. It's just a container. I guess it still kind of matters because the distribution rules and the authorization rules would be expressed either as a .NET assembly or as a Node JavaScript file. As you build your container that brings those things in. So
Yeah.
So it still might matter to some degree. But yeah, certainly as we build up to that, I want to give people the option to choose JavaScript or .NET on the server, just like they can choose JavaScript or .NET on the client.
We will see where that brings us.
Yeah.
Okay. I have, again, everything in my mind now because I was really losing the overview.
Yep, I think this is a good overview. Yeah. So once we have a nice clean version of this, this would actually be a really good picture to put on the site and on the projects.
I will clean it up, and I will send the picture to you.
Very good.
This is actually a very nice program to communicate. You probably also have on your side, you can save completely on the top left of the screen. You have a dustbin. Next to it, you have a load button, and then you have an export button.
Mm-hmm.
And there you can export the picture as it is, and afterwards you can load it again, and it stays completely changeable. Plus, it doesn't go to any of their servers. It's encrypted communication apparently.
Wow, interesting.
Yeah, because the link that I sent you includes two things. It says room number. So the first is the room, then there is a comma, and then there is an encryption key. So you can try it out if you say, for example, room equal 123, comma, encryption key Michael, for example. Well, it will create a room if 123 is not yet in use, of course. I really like this tool.
Yeah.
So
Nice. Yeah. Yeah, I was just trying that out while you were talking. Huh. That is pretty neat. So yeah, they've got the reduced trust model built in. Some people say trust no one, TNO. That seems a little bit negative to me, but trust nobody that you don't actually need to trust. Yeah. Smart trust.
Yeah, these days with internet, it's incredible. Yesterday we had a telephone problem here in the area, so telephone lines were down, and already this morning I received a telephone call, so called from the telephone company, who said, "Oh, you need to call our technical department." And so they gave me a number which was 00, so it was an international number in where was it? Somewhere in Africa. It's probably a pay number.
They're wasting no time.
I didn't call that number, and 2 minutes later they called me back. "Oh, sir, you didn't call the number yet. Do you need some help to call that number?" It's incredible these days. Everywhere they are just trying to cheat people to get your money. It's sad, but that's the negative side of internet and the communication, I think.
Yeah, that is true. But I think that there is a vision for a fix out there. That things like authorization rules, the the idea that so we talked about distribution rules. It doesn't make it makes some sense to run them on the client. An authorization rule that you run on the client for facts that you receive from the server makes a lot of sense. So now you are it's the trust but verify. These are the things that I will trust. So I receive information. Okay, let me run it through. Yep, these are coming from the right sources. So yeah.
Mm-hmm.
I think if telephone communication, text communication, email was all immutable and digitally signed and and had authorization rules, then we could build a world in which.
Let's look at the positive sides of the internet.
Yes.
Without internet, we couldn't do this.
That is true.
So, but there is still a long way to go before the world is a safe place. But okay.
Yep. All right.
Good.
Thank
Michael,
you so much,
have to go
sir.
to work, I think.
Yes, I do. Yeah, got 9:30 stand up, so I need to
Yeah.
get into the office.
Thanks a lot. And so next week I will not be there, but the week after I will.
Indeed. Yeah. So I'll open up the call next week, and so yeah, if you want to join again next week, yeah, by all means, please do. And I will see you all then.
Okay.
All
See
right.
you. Bye-bye.
Bye.
Thanks. It was fun. Bye.
Thanks. Bye.
Bye-bye.